Hi everybody, welcome to our IMAT course lesson today. Today we are solving exam 2021 section of physics and mathematics. Let's start with question number 53.
Yeah.
Okay, let's go.
Which one of the following is the simplification of this equation right here?
Okay, let's simplify it. So,
Yeah.
as usual, we are going to use some relevant equations
Rules.
to remember them.
Yeah.
Rules.
Yeah.
A plus B square equals A square B square 2 times AB. A minus B square is the same but minus 2AB, and we have 1 time plus 1 time minus. Remember that this is 2 times plus because it's square. This is 2 times minus. This is 1 time this plus 1 time minus. So it will be 1 time AB, 1 time minus AB, so it will cancel out, and we will have only A square minus B square, which is the most interesting for use.
Yeah.
This one. So let's see what we have here. So x plus 2 all square divided by x square plus 1 minus 2. So by the rules, what we can do here. So let's remember how to simplify x plus x square plus x plus b to x plus v multiplied by x plus u. Okay, how to get from this shape. Okay, it's very easy, because if you open the brackets here, you will have x square plus vx plus ux plus vu, which is x multiplied by v plus u plus vu. So the a part is v plus u and the b part is v multiplied by u. So in this case, you have x square plus x minus 2. So you need two parameters, v plus u equals 1 and v multiplied by u equals minus 2. So you have two options here, or to solve this equation, which takes a lot of time, or to find it, like to intuitively, or like to make some trials, like to try some small numbers. It's not complicated, and you will get the answer. So here we will have like 1 like minus, so you need the minus here, so 2 and minus 1. Let's try 2 and minus 1. So 2 minus 1 equals minus 2, and 2 minus 1 equals 1, so it's good. So you have x plus 2 multiplied by x minus 1. So this is the simplification. Okay, let's continue. So let's continue the question. Understand?
Yes, of course.
Okay. So let's open a new board. So x plus 2 square divided by x square plus x minus 2. So x plus 2 square, this one we will transform it to x plus 2 x minus 1. This cancels out. We have x plus 2 divided by x minus 1, which is answer A.
Yeah.
Great. Let's copy the second question.
Yeah.
Question 54. Let's go.
Yeah. Find the complete set of values of x which satisfy the inequality right here.
Okay. Let's remember some important things for inequalities.
Yeah.
So let's remember some basic rules for inequalities. So if you have A and B, so if B bigger than A and you multiply by -1, you have minus A minus B, the inequality flips. Also, you can think about it that if A is smaller than B, if you change places, you have minus B smaller than minus A. Okay, this is number one. Number two, when you have square, so A square, so if you have like A square, let me make it the B square. So if you have B square bigger than A and you want to make the root, so you have you need to take the minus side also, so you have B bigger than the square root of A, and also on the minus side you have B smaller than the minus square root of A. Okay?
Yep.
And if you have the opposite, A square smaller than B, and you want to solve it, so you will have A smaller than the positive side of the square and A bigger than the minus of the square root. What is the logic here? So if you have here 0, this is x, and you have B, you have A, yeah, so this is minus A. Okay, let's say the square root. So actually when you want the positive, the square root of B bigger than A, so you are talking about this sides here, the bigger. So bigger than the positive, bigger than the negative, absolute like negative, so it's like smaller than the negative. And this one here, you want it, if this is square root of A and minus square root of A, you want smaller. So you get this side inside, not outside. Okay? I think this is the most important things to remember when you solve inequalities. And now we can go ahead and solve this one. Let's take it to the next whiteboard, next page. So let's start. So what we have here. Okay, let's start by multiplying by 6, so it will be taking out the 2 and the 3 here. So 6 multiplied by this, we will have 3, 2x plus 3 minus 4 x plus 1 smaller than 12x. Open the brackets, you have 6x plus 9 minus 4x minus 4 minus 12x smaller than 0. How much is this? 6x, 4 is 2, minus 12 is 10. So you have 10x on the right. Let's make it slowly. So you have minus 10x. And 9 and 4, it's like how much? 5. You have 9 and 4. Okay, so plus 5 smaller than 0. So you have 10x bigger than 5, which means x bigger than 2. No, bigger than half.
Yes,
Let's see.
that's what I was going to say.
So,
bigger than half.
Yeah. Okay, this is easy. It doesn't have any complications like squares. Okay, so that's it for this. This is an easy question. Okay.
Yeah.
Next question. Okay, so we have here some geometry. So diagram is not for scale. It's not up to scale. It's not to scale.
Yep.
So you have PQR. PQ. Let's make the laser. So you have, you see the laser, yeah?
Yes.
P, Q, and R. The big
the big
triangle
Yeah.
is a right angle. Right angle means 90 degrees here. Yeah.
Yeah.
With angle PRQ equals 90. Yes, they should say which angle because it can be three options of right angle. So by this diagram, they show also diagram can show the right angle by this notation here. So this is right angle PRQ. Okay. Point S is on the side PR. So PR, you have a point S, you have 1 centimeter here, 2.5 centimeter here. Point T is on the side of RQ. RQ, you have point T, 5 centimeter, and this is not mentioned how much. Yeah. So like it can be like anything because they didn't say like they are parallel or something here. If they are parallel, so you have like the ratio may be similar, but they didn't say yet. So the line ST is parallel to the line PQ. So ST and PQ is parallel. So this can make some proportions here or some symmetry. Let's see. So you have the centimeters of this. And what is the, can you read this?
Yeah, what is the parameter of the trapezium PQTS in centimeters?
Okay.
Okay, we need the trapezium.
Trapezium P.
Yeah. QTS.
Let's see. PQTS. I want to mark it. PQTS. This is a trapezium. Okay. Okay, so we need to calculate the perimeter of this trapezium. So to calculate S, let me with laser. So to calculate ST, it's by Pythagoras. To calculate PQ, also by Pythagoras. We have here 1 centimeter, and here this one we will calculate it by similarity of the two triangles. Let's remember the rules of similar triangles. So similar triangles we have AA, which means two equal angles. We have triple S, which means all sides is the same ratio. And SAS, which is side angle side. Okay, so you have like so you have two sides same ratio, and the angle in between is equal. So what situation we have here? So we have here two triangles. We have S R T, and we have the bigger one, which is P R Q. So the angle we have and the two sides, there's proportion, and because this is parallel, so we have also here should be also proportions. Okay, so actually we have here 2.5, 90 degrees and 5 centimeter, and here we have 1, so the ratio is 1 to 2.5, which is 2 to 5. So if we have here 5, we need to have here so if we have 1 multiplied by 2.5, or 2.5 divided by 2.5, 5 also divide by 2.5, you will have 2. No, this is the small one, sorry, This is 2. No, this is not 1. This is 3. Sorry. Let's fix it. No, one minute. This is 2.5 plus 1. This is 3.5. Okay, so you have 2.5 to 3.5. Multiply by 2 to see it more clearly. So you have 5 to 7. So this one is 7. Okay. If this one is 7, so this one is 2. What we had before. Okay, so we have this one 2. Okay. So you have 1, you have 2. You need to calculate Pythagoras for the two triangles. So we have 2.5 square plus 5 square. This is ST, and PQ, it will be 3.5 square plus 7 square.
Mm-hmm.
Yeah. This need to calculate. Okay. So because we don't have a calculator in the exam, so it's hard to calculate here 2.5 square and 3.5 square. So let's find another way to calculate this. So in Pythagoras we have some known proportions that we can use, which is like 1, 2. So you have 1 square, 2 square. It's equals to 1 plus 4. It's like 5. 5 shortish 5. So because we have here the square root of 5, it's not so popular, but also let's keep it to use it. The next one is 3, 4, 5. 3 square, 4 square. This is 9 and 25. It will be 9 and 16. It will be 25. So it's like 5 here. Okay. Also we have another one proportion which is popular, 5, 12, 13. And I guess you can use also 7, 24, 25. This is the most popular. This one also is sometimes used. So this is one of the most popular. This one also you can use it for technical things. So in our case we have actually the first one. Okay, so we have, instead of 1, 2, let's use it. I will change color. So what we have here, let's use green. So in our case, instead of 1, 2, we have how much? 2.5 and 3.5. So we have 2.5 and another one 3.5. 2.5 multiplied by 2, it will be 5. Yeah, and this one will be 7. We said, yeah. So what you can do, you can use the one like 2.5. So you have like 2.5 multiplied by square root of 5, and here 3.5 multiplied by square root of 5. So what I did is I took the 1, yeah, instead of 1 I put 2.5 and kept the square root of 5. Okay, so actually we can solve it here now. How to solve it? So the trapezium is 1 and 2. You have the trapezium perimeter, yes, it's like 1 and 2 and 2.5 square root of 5 and 3.5 square root of 5. So this is 3 plus 2.5 and 3.5. This is 6 square root of 5. You can take out some 3 outside. You will have 1 plus 2 square root of 5, and I guess this that's A. Yeah, where is it? Yeah. So actually I used here some popular proportions of Pythagoras. It's not so comfortable because of the square root of 5, but it is actually helpful. Yeah, technically in the end it will be helpful.
Yeah, very.
Okay. Good. Okay, so next question. Okay, so let's read the question. So we have here a right-angled triangle, you have 5 centimeter. The area of this one is 14, and the tangents is 1/7, which means the slope. The slope is, what does it mean? The slope, that if this is 1, so this is 7 to 1. Yeah, like 7a, this is 7a. So how to start? We have the area of the triangle PQR. PQR. Let me PQR. This area. So this area is 14. So we can like calculate A. So because 7A multiplied by A divided by 2. This is the area of a triangle. Equals how much? 14. So A square equals 28 divided by 7. How much is it?
Just 4.
So A equals 2. So we can write here that this is like 2 and this is like 14. So let's calculate RP. So RP is 2 square plus 14 square, correct?
Yeah.
Which is 14 square, it's like 7 square and 2 square, to make it more easy. This is 49 multiplied by 4. How much? 160 plus 34, 194. So
196.
No, 94 plus 4. 98.
Yeah, I mean the 14. Yeah, 14 to the power of 2 is 196.
So 200 plus 4, 200.
Yeah.
Okay. So this is the square root of 200. So how to calculate now this one? Also Pythagoras, you have SP. This is 200 square root square, so it's like 200 plus 25 square root. So 225 square root. So how much is the what we need to calculate? The cosinus, yeah? So the cosinus of this angle alpha, let's call it, equals 225 divided by 200, which is 225. 1 minute. This is the square root of 225 divided.
The square root of 225 is 15.
Yeah. So how much is it? 200 divided by 25. You have like 8, I guess. Yeah. And here you have 9. So this is 3 cosinus. Sorry, I flipped it, I think. 1 minute. I think I flipped it again. The square root of 225 cosinus alpha equals 200. Yeah, I flipped it. Okay, so now cosinus alpha is the square root of 200 divided by 225. Now it's 8 and 9, which is 8 is 2 multiplied by 4, and this is 3. So you have 3 here, and you have 2 multiplied by 4, which is 2 on 3 square root of 2, which is the answer A.
Yeah.
Cool. Next question. So now it's physics. Let's read the question 57.
Yeah. At an athletics competition, a hammer thrower swings a hammer in a horizontal circle. Immediately before releasing the hammer, the ball at the end of the hammer is moving at constant angular velocity of 10 radian per second in a horizontal circular path of radius 2.5 meters, which raw in the table gives the speed and the magnitude of the acceleration of the ball just before release.
Okay, great. So what we have here a hammer, inside it a ball going in angular velocity, let's call it W, angular velocity of 10 angles of radians per second. This is the angular velocity, and the radius is 2.5 meters. So if you have remember that an angle multiplied by the radius, this is the length of the arc. In the same way, the angular velocity multiplied by the radius, this is like the horizontal velocity. This is how much he passed distance by second. So W multiplied by R, this is V. So we have 10 radians per second multiplied by 2.5 meters. So he's making 25 meters per second. This is the speed of the ball before release. This is number one. Yeah. So the speed, it should be or 20, like here, or row 1 or row 2. So next, what we have here, acceleration. Which row on the table gives the speed and magnitude of acceleration? Okay. Acceleration, centripetal acceleration, this is A. Let's change the color. This is the speed divided by the radius. Why? Here's why. Because acceleration is actually the angular speed square multiplied by r. And the angular speed, again, this is again r equals the angular speed v. So let me just one second. So v, we said, is like w multiplied by r. So what is w? It is v divided by r. So we can transform this to be including the equation with v. So this is v divided by r square multiplied by r. This is v square divided by r. By the way, we can calculate it like this also. So let's take the two options. So w is radian 10 and 25. So you have 10 square multiplied by 2.5. This is 250 meter square by second. Also, you can calculate it v square divided by r, and v is 25. So you have 25 square divided by 2.5. Here you need to calculate 25 square. I think 5.
It's 625.
625 divided by 2.5. Looks like 250. The same answer. So you have 250. The answer is A.
Yeah.
Okay. Question 58. Yes.
Yeah. A hydraulic jack consists of a piston with a small cross-sectional area connected by a tube to a piston with a larger cross-sectional area. The cylinders of the piston and the tube contain oil.
Wow. Okay, so you have Pascal principle. So the proportions of the forces equals the proportions of the area. So actually in this case you have F2, I like to write it like this, F2 equals F1 multiplied by Y on X. So we amplify F1 to F2 by the proportions of the area Y to X. The hydraulic jack is, all this machine is a hydraulic jack. This is the tube. This is the piston, first one. This is the second piston. So pushing down on a small area will be amplified, leveraged to push up on a bigger area by Pascal law. So actually if you will push down 1 Newton, here you will have Y on X newtons. And this is the hydraulic jack. Okay, let's see the question.
Yeah. A downward force F1 is applied to the smaller piston, which results in an upward resultant force F2 being exerted on the larger piston. Points X and Y are in the oil immediately underneath the pistons, which are at the same height. Which of the following statements about the pressure and forces in the hydraulic jack is or are correct?
So the X and the Y are points, not the links of the piston. Let me see here. Okay, so let's call this A and this links B and fix the equation here. So it will be A, B, B, A. Okay, so on this point, the pressure is this is a point of pressure and Y is a point of pressure. So let's see number 1.
The pressure at Y is less than the pressure at X. No.
It's a point, yeah?
No.
So the pressure on these points X and Y are equal. So actually Pascal say that the pressure on X equals the pressure on Y. This is actually the law. That's why we have a different force, because the area is bigger. Okay, so this is the difference of force will be different. So like F1 multiply by A. 1 second. So pressure, the definition of pressure is how much force pushed, divided by area. So it's equal. So from here we had the previous conclusion. So F1 divided by B equals, well, that's like let's just multiply by B. So you have F1 multiplied by BA equals F2. Yeah. So if there is a difference between the areas, it makes leverage and hydraulic force F2. Okay. So again, the pressure on X, which is F divided by A, is the same pressure on Y, which is F2 divided by B. So the first statement is not correct. 2.
The pressure at Y is equal to the pressure at X.
Which one is greater? I think F2 is greater
than,
because
F1.
B is bigger. Yeah?
Yeah.
So this one. So the answer is 2 and 3 only. That's right.
2 and 3,
okay.
yeah.
So this is a system how actually hydraulic jacks are built. So you push on a small area of oil and then it will be leveraged because the area here is bigger. So the force will be bigger because the force divided by area should stay constant by Pascal law, and this is the tube between the two, so you can hear like hold very heavy weight and push here less newtons, okay, less force. What I want to add here, that the height is not equal. So for example, and this is a very important point to remember, if you push down let's say alpha, so the quantity of oil is alpha multiplied by x, and the same volume of oil will be pushed up here, and this height beta will be not equal to alpha, it will be smaller because it's like divided by y. So beta y, let's calculate like this, so the volume is beta y should equal alpha x. Sorry, not x and y, this is a and b, I'm confusing by point. And so alpha a, this is the volume, yeah, of how much oil you pushed down. And you can see here the volume is less high, have less height. So beta, this height, beta, because this is a goal to lift the car up in some height. So beta multiplied by b should equal alpha multiplied by a. So actually beta is alpha multiplied by a divided by b. So yes, it's true that we push easier to lift up the jack, the car, but we need to push like if the proportions are 1 to 5, so it's 5 times more easy to push, but you need to push 5 times to have the same height of what you lifted. Okay, so this is also like important to remember. So there's a price. So there's a price here for the hydraulica. So there's a price we pay by lifting more easy. This is like lifting more times and more height. Okay, next question. Okay, question number 59.
Yes. A metal has a specific heat capacity of 500 joules, kilogram Celsius. A block of this metal has a mass of 1.2 kilograms and is provided with thermal energy by a heater for 5 minutes. The temperature of the block increases from 40 Celsius to 90 Celsius without a phase change. What is the power of the heater? Assuming that no thermal energy is lost or gained from the surroundings and that the metal is at uniform temperature all the time.
So basically the question here is like how much power we need to heat up the metal temperature. Okay, so let's summarize like what we have here information. So we have the mass, how much? 1.2 kilograms, correct?
Yeah.
Okay.
Yeah. Heat capacity we have.
Heat capacity, specific heat capacity. This is
the C.
Yeah, I will write now the equation. So the equation is Q equals
Q
MC delta T. So
delta T.
let's use exactly this notation. So MC is 500 joule
per kilogram.
And also we have time. How much time?
5 minutes. 5 minutes.
Okay, time we will use it for later, because this is the energy, yeah. But
Yeah, so delta T is the
power,
temperature. We
this
need the
is energy, and the power. What is power? Power is energy by time. So time, we will use it also, but for the other equation. So time is 5 minutes.
Yeah. And the
Wait.
temperature.
Remember that we have here energy is joule by second. So 5 multiplied by 6 is 300. This is 300 seconds. Okay?
Yeah.
Temperature will need to rise, delta T, T2 minus T1, temperature. This is not time, this is temperature. This is 90 minus 40, this is 50 Celsius. So we can start solving. It's easy. So 1.2 multiplied by 500 multiplied by 50. 5,500, this is 25,000. Another 5 is 30,000. So this is 30,000 joules. And 30,000 joules, the power is 30,000 joules in 300 seconds.
Yeah.
100. And
100 watts. 100 watts.
Exactly. Watts are joules by seconds, which is the answer A.
Yeah.
So they gave us the mass, the specific, code for this material, specific heat capacity of this material, time, and the difference in heat. So the energy is how much heat you can raise in this mass, and if you want to calculate power, so you need to calculate in how much time you gave this energy, and this is like 100 watts. Okay, last question. Okay, last question, 60. Let's read it.
Which of the following expressions give a quantity that can be measured in joules?
Okay.
Assume that all quantities are magnitudes. Yeah.
Assume that all the quantities are magnitudes. Okay.
Yeah.
I think we need to remember joules from where we have joules. Okay, so let's remember before we solve it, like what is joules and energy. So we have mechanical energy, which is work equals force to distance. So if you apply a force, this is newtons, but if you apply this force for a distance, you already have work, energy. Okay?
Yeah.
So this is force by distance. Also, you have kinetic energy. This is mv squared divided by 2. This is kinetic energy. You have potential energy, mgh, and also if also energy or work is if you change this distance to velocity, so you will have also power multiplied by time. You can have it also like power multiplied by time is energy, because power is energy divided by time. So I will write it separately. So because power equals work by time, so work actually is power alongside with time, like power times time. Okay. This is in mechanics. We have also in electric energy and thermal energy and others. So let's take a look at the units. So here you have Newton multiplied by meter. Okay, Newton is kilogram. So also you know, F equals ma, so it's kilogram by meter on second square multiplied by meter, so it will be kilogram meter square second square. This is a joule. Next, this one is kilogram meter square on second square, so this one is the same, yeah. This is kilogram meter square second square. We saw it already, yeah, previous, like in the previous one. This one kilogram, m is mass, kilogram, g is acceleration, this is meter square, meter on second square, sorry, and this is meter. So again we reach the same conclusion like up. Okay, yeah. This one is watts multiplied by seconds, so it's also joule, because we know that joule is watt by joule divided per second, this is watt, so it's also this one. So from here we conclude that Newton meter, kilogram meter square second square, and watts multiplied by time. Okay, this is mechanical energy. Let's continue. Let's remember everything, like it's a good summary we will have. Regarding electrical energy, so you have electrical energy, yeah, yeah. In electrical energy, you have energy. This is volt by current with time, and you can like you know, write it differently: current square R with time, or V square with R with time. All this is energy. All of them are joules. So if you calculate the, let's see, so here we have volt ampere second. This is a joule also, so volt ampere second. Here you have ampere square ohm second, it's also a joule. And here you have volt square ampere, it's also joule. And you can continue, you can speak about thermal energy. Let's remember the equations. So as we said now, Q is mc delta T, so you have kilogram multiplied by joule on kilogram and Celsius. So this one will like it's actually, the C is like defined by, so this is nothing here, this is just joules because of the C. You have heat, ml, also G, there's nothing to like also here is L because L is defined by this. Okay, what also we have, If you want to speak about like elastic energy, which is half kx square, in this case we will have Newton. This is, if you calculate it, will be Newton meter. So we had this before, nothing new, but it's good to remember that elastic energy, you have this also. That's it. I think that's it. So you have kinetic, electric, thermal, and elastic, which is kinetic also. So in conclusion, if we conclude here all the units, only units, so joule, we saw it as Newton multiplied by meter. We saw it that it's equal also kilogram meter square second square. And we saw it also watt multiplied by time. And here we had some volt ampere second. This is also here special. We can take one of them, which is like volt square on ohms. Also it can be volt square on ohm. Okay, now we can, I think, safely, easily look at the answers. Yes, let's look at the answers.
Will we go one by one? Will we go one by one?
Let me copy it to another whiteboard. So we'll have space to write. Okay. Yeah, let's go one by one. Yeah, let's take it one by one. Yeah, first one.
Momentum multiplied by velocity.
So momentum and velocity. Momentum and velocity. What is momentum? Momentum is
mass multiplied by
momentum is
velocity.
how much mass multiplied by speed. Yeah, this is the momentum, which is a kilogram multiplied by meter by second, multiplied by velocity, which is again meter by second. And we see here, yes, kilogram meter square second square. We saw that this equals the joule, correct? Here we see that this is this one, so it's correct. So we have momentum multiplied by velocity becomes energy. Okay, next one, B. This is A. So this is true. B.
Charge square multiplied by resistance.
Charge square multiplied by. So this is C square multiplied by ohm.
Or I square.
Wait, B. Let's see if we have it here. We don't have it here.
No.
Okay, let's see something similar. C. So what is C? This is ampere by second. Capacity is ampere by multiplied by seconds. Like how much ampere, how much you charge. Like if you charge something, amperes multiplied by seconds. Like how much amperes multiplied by how much seconds. This is square, and this is ohm. So you have a square second square ohm. We don't have something like this. Resistance is ohm is actually voltage by ampere. So we take out the ampere, so you have a s square v. Let's see if we have something similar. AVS, you say AVS and not AVS square. So this is not correct, because joule is ASV. We saw it from before. Okay, so this is not correct. So C. Yeah.
Mass square multiplied by velocity.
Kilogram square V. don't have something like this, yeah?
No.
This is not energy, so you don't have it, so this is not correct. D.
Specific heat capacity divided by mass multiplied by temperature change.
So actually specific heat capacity, this is joule. Mass, this is kilogram. Temperature changes like actually in the units of Celsius. Yeah? And that's it?
We have E as well.
No, wait. Specific heat capacity. No. Heat capacity. 1 minute. Actually, this is like this. This is the heat capacity. This is the heat capacity. Divide by kilogram Celsius. It will be joule, kilogram square, Celsius square. This is not joules. Okay? This is not joules because you have joule up. And E, the last one, voltage
divided by current by
and time. This is not correct because the correct one is ASV. Okay? So, just in time, 2 hours. The answer is A. That's the exam 2021, yeah? The physics and mathematics section.
Yes.
Thank you very much.